Hello, 7th grade. It is Tuesday, April 21st, and we're talking about lesson 103. It's got a lot of things going on in the big title. Powers of negative numbers, dividing terms, and square roots of monomials. So let's dive right in talking about powers of negative numbers. Now let's first just look at a pattern here. -1, I shouldn't even have it in parentheses, just -1 by itself has a value of -1. Wow, okay? But -1 times -1 is a positive 1. A negative times a negative times a -1 becomes a -1. And then if you take those three -1s and multiply it by another -1, you get a positive 1. Now let's notice the pattern here. When we have an odd number of negative factors, here we have 1 or 3. If we have an odd number of negative factors, our answer is negative. If we have an even number, here we have 2, here we have 4, and we have an even number of factors that are negative, our product is positive. So we can talk about a general rule. An even number of negative factors gives us a positive product, but if we have an odd number of negative factors, we're going to get a negative product. Now that can be really, really helpful when we talk about a big, long string of factors that are integers. And so I've got a lot of positives and negatives going on here. Well, let's first of all count and see how many negative factors I have, because the positive factors will have no effect whatsoever on the positive or negative solution I have or product I have. But let's look at the negatives. So how many negative factors do I have? I have a -2, a -1, and a -2. I have 3 negative factors. Well, 3 is an odd number. So if we have an odd number of negative factors, we're going to have a negative product. And so right away, this product is negative. I don't even have to worry about my multiplying positives times negatives and negatives times negatives anymore. I can just count the number of negative factors I have, and if it's an odd number, the product will be negative. Okay, now if it's an even number, it will be positive. So now all I have to do is just look at my numbers themselves. 3 times 2 is 6. 6 times 2 is 12. 12 times 1 is 12, and 12 times 2 is 24. And my answer is negative, because I had 3, or an odd number of negative factors. Now, let's look at something else. What if I raise a negative number to a power? Well, that's -2 to the 4th power, which is -2 times -2 times -2 times -2. I have an even number of negative factors. Okay, so what is my final product going to be? It's going to be positive. And so I simply know that my answer is positive, so now all I have to worry about is what is 2 times 2 times 2 times 2? Well, I will tell you the answer is 16, and it is going to be a positive 16 because I have an even number of negative factors. Now, what if I have an odd number of negative factors? Well, we know the product is going to be negative. So my answer here is going to be negative, and now I'll have to think about 2 to the 5th power. Well, 2 to the 4th power is 16, so 2 to the 5th power, I'm just going to add on another factor of 2. 16 times 2 is 32, and my answer is a -32 because I had an odd number of negative factors. Okay, now let's move on to something different. That was powers of negative numbers. Let's talk about dividing terms. Now, so far we have added or combined like terms. We have multiplied algebraic terms. Today, we're going to divide them. And I think that you're going to like this. Now, the first thing I'm going to do here is I'm going to go ahead. I have 12x cubed yz squared over 3x squared y. First thing I'm going to do is go ahead and cancel my numerical factors. Well, 12 over 3 is 4 over 1. Okay. Now, I'm going to put a fraction bar here. I'm going to go ahead and put the 4 here. And I'm going to go ahead and write out x cubed. I'm going to put dots here. X times x times x. Now, I've got 1y. And then I've got z squared, I've got 2 z's. Remember, that squared only goes with the z. The y has an invisible exponent of 1. There's only one y. Now in the denominator, I've got two x's, x squared. I'm going to write those out, and then I've got a y here. So all we have to do is cancel. Now, I've got x over x, x over x. Those are going to cancel out to 1 over 1. And then what else can I cancel? My y over my y. Well, these all really canceled out to 1 over 1, because anytime you have the same factor in the numerator and denominator, you can cancel out 1 over 1. And so what am I left with? Well, I'm left with all ones in the denominator, so I don't even need a fraction bar anymore. I'm just going to write what's left in the numerator. I've got a 4 here. I've got one x left that wasn't canceled out, and I've got two z's. So I'm going to rewrite that as z squared. So this original fraction simplifies to 4xz squared. I cancel out my common factors. Now let's go to this last one. I'm going to go ahead and let's go ahead and reduce the 10 over 8 to 5 over 4, okay? So I'm going to put a 5 here and a 4 here. Now, let's go ahead and write our variables out. I've got an a cubed, that's 3 a's. I've got 1 b, and I've got 2 c's. Down below, I have my 4 already. I've got an a, 2 b's, and a c. Okay, now let's go ahead and cancel. So I've got an A and an A are going to cancel out. What else? A B and a B and a C and a C. And let's see what we're left with. 5A squared C over 4B. And that is my answer. I'm just simply canceling. Now, let's go over here to the other flip side. And let's see what we have over here. I'm going to move that over a little bit so we can see. Okay. Now, I have the square root of 36 x squared y squared. Now, we've done the square root of 36. We know what that is. But what is the square root of x squared? Well, what times what would give me x squared? Well, x, of course. And so this is simply going to become the square root of 36 is 6. The square root of x squared is x, and the square root of y squared is y. And that is how we do it, okay? Now, let's do something a little more complex. Let's start with the square root of 4. It is 2. The square root of x squared is x. But what is the square root of y to the 4th? In other words, what times what? What term multiplied by itself would give me y to the 4th? Well, what about y squared? Y squared times y squared equals y to the 4th power. We add the exponents. And so the square root of y to the 4th is y squared. Now look at what, there's a little special pattern here that kind of makes this easy. When I'm taking the square root of a variable term raised to a power, to take the square root, I simply divide the exponent by 2. 4 divided by 2 gives me y squared. X squared, 2 divided by 2, gives me 1x. And so, if you have even numbers here, you can take the square root of variable terms. Okay, I'm not going to give you one with odds. Don't worry about odds. That's more for when you get to honors, well, it gets to Algebra 1 or Algebra 2. But for right now, if you have even numbers for your exponents, you can take the square root by dividing the exponent by 2. Okay, now these radicands, these numbers under the square root, here and here, are called perfect squares. Perfect squares are numbers that we can take the square root of. Now we know numbers that are perfect squares: 1, 4, 9, 16, and 25. Can I take the square root of those? Well, the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5. These are perfect squares. They are squares of numbers. Now, is 36 x to the 4th, y to the 8th a perfect square? Yes, it is. And the reason we can tell it is because the number is a perfect square. Its square root is 6. And these have even exponents. So we call this a perfect square because we could take the square root of it. And this would be 6x squared y to the 8th. But it's only asking us, is it a perfect square? And the answer is yes, this one is. Now let's look at the next one. Is this term a perfect square? Well, I've got even exponents. That's good, 2 and 4. But is 8 a perfect square? No, it is not. The square root of 8 does not give me a whole number. Okay, there is no square root of 8 that will give me just a simple number. All right, there's no number times itself that will give me 8 for a product. So the answer here is no. Okay, let's look at the last one. 4x squared y. Is this a perfect square? Well, let's start with the 4. Yes, square root is 2. X squared, even exponent. The square root would be x. Y. Is this something I could take the square root of? Is its exponent an even number? No. Actually, its exponent is an odd number, 1. Okay, so it does not meet all the qualifications. The leading number here must be a perfect square. The exponents must be even. Okay, now let's go to the homework. So go ahead and get out your worksheet and let's look at number 29 and number 30. Let's look at number 29 and number 30. Okay, number 29 has 2 parts, A and B, and they included this one because it has 3 negative factors, so we can remember our rule on that we learned right at the beginning of this lesson. Okay, first of all, I have 3, an odd number. A 3, an odd number of negative factors means my product is going to be negative. So it's going to be a negative number, and 3 times 2 times 1 is 6. So this entire product up here is negative 6. All right. Now, here I have the negative of the absolute value of negative 3 times 2. Now, I'm going to stick the negative right here. Let's first figure out what is negative 3 times positive 2. It's negative 6. Well, what's the absolute value of negative 6? The positive value of negative 6. That's what absolute value is. You just take off the negative. And so the absolute value of negative 6 is 6. And so I'm going to put that here, but I also had this negative sign here. Okay. So I have a negative 6 over the negative of 6. So what's negative 6 divided by negative 6? My final answer, positive 1. Okay, now let's go to B. We have 3 squared. Let's go ahead and simplify that. 3 squared is 9 minus, okay. Now, let me say this. You cannot make that a plus plus right now because PEMDAS says that I have to do parentheses, then exponents before I multiply and divide and before I add and subtract. And this is subtraction. I cannot do subtraction by changing that to a plus plus. I have to do the exponent first. So I'm going to leave the subtraction there, and negative 3 squared is negative 3 times negative 3. Well, negative 3 times negative 3 is 9, and so my answer is 0. 9 minus 9. Okay, now let's go ahead and do one of our division of our exponential terms. All right, now you can cancel out the 6 over 2 now, or you can wait. I'm going to wait this time just because I want to do something different, but it's okay. You can go ahead and cancel it now. It doesn't matter. Now let's go ahead and write the a cubed out. A times a times a. B squared is b times b, and I've got 1c. Down below I've got a 2 times an a times a b times a c. Now I'm going to cancel. Well, 6 over 2 is obviously 3 over 1. Okay, you can cancel that in the first step or the second step. Let's cancel out an A over an A. What else are we going to cancel out? A B and a B, and a C and a C. Now we have to be really careful. What are we left with? Well, when everything canceled out, remember those become 1 over 1s. And so everything in the denominator is gone. But I got to be careful here. I've got a 3. I've got 2 A's. So I have A squared, and then I have a B. And there is my simplification of this division problem using variable terms. okay? It's easier, in my opinion, than adding like terms, and it's easier than multiplying like terms. We save the easiest for last. That should make you happy. Okay, now let's take the square root of this problem. It's the square root of 9. Let's start with that. We know that's 3. What's the square root of x squared? Well, we take the exponent and divide it by 2. 2 divided by 2 is 1, 1x. Now, what is the square root of y to the 4th? Take the exponent and divide it by 2. Okay, well, 4 divided by 2 is 2, and so I end up with a y squared. And there is my square root. Now, what do we have for omissions today? Okay, get ready to X these out. 1, 2, 5, 7, 8, 13, 16, 18, and 20. Let's repeat those. 1, 2, 5, 7, and 8 on page 1. 13, 16, 18, and 20 on page 2. And I have helped you with 29 and 30. So, we did a lot today. And I hope you're doing well. I see my 4 or 5 people at Zoom every day. I'd love for more of you to join. I'll go ahead and post the password and the meeting ID if anybody else would like to join us. So anyway, I hope you have a blessed Tuesday, and I really miss you, and hope that I will get to see you soon. All right, bye-bye.